Welcome back to math. In section 6, we'll talk about solving equations. We'll talk about treating both sides the same, how to combine like terms, and how to check your answer. An equation has an equal sign. That means that whatever is on the left has the same value or is equal to whatever is on the right. For example, 3 plus 2 equals 5 is an equation. An equation is different from an expression because an expression does not have an equal sign. 3x squared plus 4 is an expression, but not an equation. Equations may contain variables, such as x or y. A variable can be any letter or symbol that stands for a specific value that is unknown. We solve equations to find the value of the variables, making known what is unknown. Therefore, the solution should be something like x equals 4, which means that the value of 4 makes the equation true. It's important to remember that both sides of an equation have the same or equal value. So we can do the same thing to both sides and they will still be equal. We can add, subtract, multiply, or divide both sides of an equation by the same value and the equation will still be true. Look, for example, at x plus 7 equals 12. That means that there is some unknown number represented by x, and when that number is added to 7, the result equals 12. Our goal is to find out what that unknown number is. So if we subtract 7 from both sides, some people like to list here subtract 7 and then show how they're doing it. So on both sides we've subtracted 7, and I'm lining this up very carefully. X plus 7 minus 7 leaves just x, and 12 minus 7 equals 5. So the solution to this problem is that x equals 5. We can confirm this is right because indeed if you take 5 and add 7, you get 12. It wasn't a random decision to subtract 7 from both sides. The goal of solving the equation is to isolate the variable, meaning to get it all alone on one side of the equal sign. So to solve an equation, we undo what is being done to the variable. In this case, the number 7, the value of 7 was being added to x, so we did the opposite. We subtracted 7. It's very important to remember that addition and subtraction are opposites. Addition undoes subtraction, subtraction undoes addition. And also multiplication and division are opposites. We undo multiplication by doing division. We undo division by doing multiplication. What if the equation involves both addition, subtraction, and multiplication, division? What do we undo first? Well, usually we tend to undo the addition and subtraction first. So look at this example. 3x plus 4 equals 19. Let's start with the addition here. So 4 is being added. We'll do the opposite. We'll subtract 4 from both sides. So plus 4 minus 4 cancels out, leaves with 0 really. We're not going to even write that down. So 19 minus 4 equals 15. Now we have 3 times x equals 15, so we'll do division. Instead of multiplying by 3, we'll divide by 3, and we get x equals 15 divided by 3 equals 5. Here's another example. X divided by 2, remember a fraction means division, and then minus 3 equals 7. We'll start by adding 3 to both sides since 3 is being taken away from this side. So x minus 2, or x divided by 2, minus 3 plus 3, that cancels that out. We are left with x divided by 2 on this side, bringing the equal sign straight down. 7 plus 3 is 10. Now x is being divided by 2, so we're going to multiply both sides by 2. That makes this essentially cancel out, and we are left with x on this side equals 20. As long as we always carefully do the same operation to both sides, we will still have a true equation. However, not every sequence of operations will produce a result in the fewest number of steps, or with the least amount of work. What if, same example that we just did before, but what if we undid the division first? Would we still get the right answer? Sure, but it's going to take a little bit of extra work. If I decide to undo this division first, and I want to multiply both sides by 2, I have to remember that I have to multiply, really I have to distribute 2 on the whole thing. I can't just multiply this term by 2. The whole side of the equation needs to be multiplied by 2. So here, this would be 2x divided by 2 minus 6, right? And now I've got to do the same thing on this side, equals 14, 7 times 2. Now these can cancel out, and I have x minus 6 equals 14. Now I can add 6 to both sides, and x equals 20. I got the same answer that we did before, but it took a little bit more work. There's nothing wrong with this approach, but it took a little extra work, and it sometimes makes our mistakes a little tougher to spot or correct. But with some practice and experience, you'll know what to do first. So now we'll talk about combining like terms. Remember that terms are the pieces of an equation that are separated by addition and subtraction. Like terms have the exact same exponents and the exact same variables. So for example, 4x squared and 9x squared are like terms, the same variable with the same exponent. Their numbers out here, the 4 and the 9, those are called coefficients. Those are different, but that's okay. It's the variable and its exponent that makes the terms like. So 5xy and 12xy are also like terms. They have the same combination this time of variables, and they're both to the same powers. But 5x squared y is not the same, it's not a like term with 5xy. So when we're solving equations, combining the like terms is almost always a good first strategy. So consider this example, 3x plus 3 plus 9x equals 27. There are two x terms here, the 3x and the 9x. Before we do any other operations to both sides, we should combine those terms. How do we do that? Well, 3x plus 9x is 12x. And remember, in fact, that 3 of anything, 3 things plus 9 things is 12 things. It doesn't matter what those things are. So I also have plus 3 equals 27. So now let's subtract 3 from both sides. That cancels out this side. We're left with 12x on that side. 27 minus 3 is 24. Now let's divide both sides by 12. And we'll get just x here equals 2. Here's another example where we have like terms, 2x and the 8x. This time they're on both sides of the equation. So how do we combine those like terms? Well, let's start by subtracting 2x from both sides. It doesn't affect the other terms, we're just subtracting the x terms. That lets it cancel out on this side, and we're left with 15 here equals 8 things minus 2 things is 6 things, and we have minus 9. So now we'll add 9 to both sides. That will leave us with 6x on this side, and 15 plus 9 is 24. Now we'll divide both sides by 6. Why? Because x is being multiplied by 6, so we're going to do the opposite. Divide by 6. That leaves us with x on this side. 24 divided by 6 is 4. So the answer is x equals 4. In fact, I say x equals 4, but it looks like 4 equals x. That's, of course, perfectly okay. It's all right to have the variable on either side of the equal sign. And also, another thing to notice here is that when we combine like terms, we subtracted the one with the smaller coefficient. We subtracted the 2x instead of subtracting the 8x. I could have absolutely done it the other way. It would have meant that I would have had a negative 6x on this side, and I would have had to deal with some negative numbers. Absolutely nothing wrong with it, though. Perfectly okay. Finally, when we talk about solving equations, we need to talk about how you can check your answer. How can you be sure that your answer is right? Well, first, take the value that you got for your answer. This is the same problem we just did, and we discovered that x equals 4. So substitute your answer, that was x equals 4, for every variable. So every time I see an x, I'm going to write a 4. Now I've written them in parentheses because I want to show that this is multiplication. This really stands for 2 times x, right? When things are next to each other without any other operation being shown, we assume that that's multiplication. So now, every time I have an x, I have a 4, and now I can start doing these operations. And we'll do it in order. 2 times 4 is 8, and 8 times 4 is 32. So there's the multiplication done. Now we'll do the addition and subtraction. 8 plus 15 is 23. 32 minus 9 is 23. So that's true. 23 does equal 23. So the answer checks out and it's right. If you go through this process and you get a result that isn't true, like 3 equals 4, then you know either your original answer was wrong or maybe you made a calculation mistake when you checked your work.